Welcome dear student friends. Today we will all be studying about a class of organic reactions, that is the rearrangement reactions. So, what is a rearrangement reaction? In a rearrangement reaction, a group moves from one atom to another atom within the same molecule. Now, let us take a look at the reaction given in this slide. Here we can see that the atom W has migrated from atom A to the adjacent atom B within the same molecule. Such type of reaction is called a rearrangement reaction, and it is an example of 1-2 shift, and they are very common type. But there are also examples of rearrangement reactions where migration occurs over longer distances too. In general, we can define a rearrangement reaction as any chemical process involving the breaking and forming of sigma and pi bonds in which atom or group moves from one atom to another, resulting in structural reorganization of the original molecule. Now let us learn about some most common terms used in rearrangement. The first term that we will learn is the migrating group. Here in the example given in this slide, it is shown that W is marked as the migrating group because it is that group or atom which migrates during the course of the reaction and is being rearranged. The second term that we will learn is the migration origin. Migration origin is that atom to which the migrating group will be attached during the starting of the reaction. In the example given in this slide, it is shown that W is attached to A. So, A is the migration origin. The third term that we will learn is the migration terminus. Migration terminus is that atom to which the migrating group or atom will be attached after the reaction takes place. In the example here, we have seen that atom B is the migration terminus. Let us now discuss about the categories of rearrangement mechanism. There are, in general, 3 categories of rearrangement mechanism. The first one is heterolytic rearrangement. Here, initial fragmentation of the bond between migrating group and migration origin gives rise to a positive or negatively charged species, which can undergo rearrangement. There are 2 types of heterolytic rearrangement. As you can see in this slide, the first type is called nucleophilic or anisotropic rearrangement. This type of rearrangement occurs when the migrating group retains the electrons. The second type is called electrophilic or cationitropic rearrangement. This type of rearrangement occurs when the migrating group gives up its electrons. It should be noted that in the heterolytic rearrangements, there should be an electron deficient or electron excess site adjacent to the migration origin, furnishing the migration of the migrating group. The second category of rearrangement mechanism is the homolytic rearrangement. Here, initially, homolytic bond cleavage takes place to produce a radical species possessing an unpaired electron prior to migration. The last and the third type of rearrangement mechanism category is the pericyclic rearrangement. These type of rearrangements are single-step rearrangement, and they normally do not involve the formation of recognizable intermediates. Once upon a time, these mechanisms were referred to as no-mechanism reactions. Now, let us summarize the points to remember about the categories of rearrangement mechanism. The first point that we should remember is that all heterolytic rearrangements, whether it is nucleophilic or cationitropic rearrangement, they are polar in nature. The second point that we learn and should remember is that homolytic rearrangements are usually non-polar, though there are examples of reactions involving charged radical intermediates. The third point that we should know and remember is that the pericyclic reactions are generally very non-polar in nature. The fourth point that you should learn is that among the nucleophilic 1,2 shift, the electrophilic 1,2 shift, and the homolytic 1,2 shift, that is the free radical 1,2 shift, the nucleophilic 1,2 shifts are much more common. Now, what is the reason behind them? The answer to this can be explained when we draw the transition state of all the three types of rearrangement. Here we can see that the 2-electron AW bond overlaps with the orbital in atom B, which contains 0, 1 and 2 electron respectively in the case of nucleophilic, free radical and electrophilic migration. The overlap of these orbitals will give rise to three new orbitals which have an energy relationship diagram as shown above in the picture. That is, it will have one bonding and two antibonding orbitals. Now we can see that in a nucleophilic migration only two types of electrons are involved, and both these electrons will occupy the bonding orbital. But in case of free radical or electrophilic migration, electrons occupy the antibonding orbitals. In case of free radical, there is one electron occupying the antibonding orbital, whereas in case of electrophilic 1,2 shifts, there are two electrons, one electron each in the antibonding orbitals. So we can say that from the energy profile diagram, the transition state for nucleophilic 1,2 shift is the most stable among all the three transition states. Thus, consequently, we can say that nucleophilic 1,2 shifts are much more common. So, with this, I would like to end my lecture today. In our next class, we will study about the modes of rearrangement and their determination and the subclassification of heterolytic rearrangements. Till then, eat healthy, stay healthy and safe at home, and remember, keep learning and grow wise. Thank you.